Okay, question 10.4. So we have a VFD and a motor that we want to run at 4,000 RPMs. It's a two-pole motor. And the question is, what frequency do we need to set the VFD at to have the motor spin at a 4,000 RPM? And we're going to simplify this problem slightly. We're going to assume that the 4,000 is a synchronous speed. And we can then assume if we want the 4.2% slip that we could find the rotational speed, but for right now let's keep it simple. We'll do 4,000 RPMs as our synchronous speed. So that will be our synchronous speed. If we recall, we have synchronous speed equals 120 times frequency divided by number of poles. Okay, we can rearrange this equation. We can move things around algebraically to solve for frequency. Okay, if we move everything on the other side except frequency, we will have frequency equals synchronous speed times p poles over 120. Okay, so if I move the 120 and the poles to the other side, I have to inverse it. Okay, so this is the equation now we're going to use. So we'll find our frequency that we need to run our motors at a specific synchronous speed. So we have 4,000 RPMs, we have two poles, we have 120 as a constant. So that will be, this is rounded to 66.67 repeating hertz. So we would need to set our VFD to 66.67 hertz to achieve a 4,000 RPM synchronous speed. If we would want to determine now what is the actual rotor speed, what is N? So what's N for this motor? How fast is the rotor spinning? We can pull out our N equals our synchronous speed times 1 minus slip divided by 100 equation. And we can work this through. Looking at synchronous speed, we have 4,000. We're assuming our slip is 4.2% divided by 100, and again you put that in as 4.2, and you come out with 3,832 RPMs. Rotational speed, the speed at which the rotor is spinning. Okay, so this is how we could calculate back to find our frequency that we need to spin a motor at this synchronous speed, and also what rotational speed would that correspond to. Problem 10.5. So in problem 10.5 we have a motor. It has a 60 Hertz system. It has a full load speed 1,725 RPM, 60 Hertz. Now this speed, full load speed, it's synonymous with just the N, the rotational speed at full load. Okay, this is also the speed that you'll see stamped on the nameplate, will be the full load speed. Okay, so that's the kind of speed when you look at the nameplate they're talking about. So the question is, if this is my rotational speed, let's actually calculate what my percent slip at full load will be. Now I've said it's roughly 4.2%. Let's actually run the calculation. So if we pull out our slip equation, it's synchronous speed minus rotational speed at, and we're going to use the full load, divided by our synchronous speed. All of that multiplied by 100 to get our percentage. Okay. Now, if we have a 1725 RPM nameplate motor, we can look at table 10.1 to find our synchronous speed RPMs. If we do that, if we look at table 10.1, we'll find that's 1800 RPMs. So that's table 10.1. We'll find that if we reference the full load speed of 1725. And then we want to subtract our 1725 RPMs. Divide that by our 1800 RPMs. And multiply that by 100. So we're going to come out with an answer rounded to 2 decimal points, places at 4.17%. So this is a percent. Okay, slip is in percent. So that's where we get the 4.2. You round to 1 decimal place, you get the 4.2%. Okay, this is how we would determine our slip based on our synchronous speed, and then we can put whatever speed here we want, whether it's full load speed, locked rotor speed. Of course, locked rotor speed is 0, right? So if we're running at 0 speed, we are 100% off the synchronous speed, right? But we could put other breakdown speed, different speeds in there. Remember, a motor is undersized if the synchronous speed is less than or equal to 2% when running at full speed, full load rather, when the motor is at full load torque. So if we have a situation where we have a motor running at full torque, full load torque, but our slip is 2% or less, then that motor is undersized. Okay, that's a clear symptom of an undersized motor.